All right, so here we go with the example number 2 for Poisson. This should be, I think, a little bit easier now that you've got a little bit more comfort with Poisson, but let's go ahead and work through it anyway. All right, so we've got trains at a local railway station are occasionally canceled due to staff shortages, breakdowns, lack of available trains, and many other causes. Assume that there are on average 2.31 canceled trains per day, and that the number of canceled trains C can be modeled by C is a Poisson distribution with the parameter of 2.31. All right, so what we want to do is find the probability that there will be 4 or more cancellations on a given day. All right, so we'll start with that. So 4 or more. So that means that we want to show the probability that C is greater than or equal to 4. So this is going to be a Poisson CDF. And we'll go ahead and do it on our calculator. So we go into our distributions, or you can write it out. I'm going to go ahead and write it out because you know how to get there now. So Poisson CDF, and then we're going to put in our parameter of 2.31, which was given to us earlier. Once we put in the 2.31, then we put comma, and then we put the range that we want to look at. We want to do everything that's greater than or equal to 4. So I'm going to put in the 4. And then I'm going to go comma, and we've used the number 10,000 before, so I'll use that just to show that it needs to go really big. If you want, you can always do 1 minus the probability that C is less than or equal to 3, and you could do Poisson CDF on that if that makes you feel a little bit better, because then you could go from 0 to 3. So that's all that you need to do, and we push enter, and we get our answer. So there you go. There's the first one done. We get a value of 0.203. All right, so for the second one, so let's go ahead and put that down, 0.203. All right, let's go on to the second question, which is now the probability that there will be at least 81 cancellations in the month of March. Okay, now this is changing. Remember before it was giving us per day, 2.31 per day. So that's the expected value. Remember, that's our parameter, which is the expected value of Poisson, and that is per day. Now, if we want to do it in a month, well, March has 31 days, and so we'll need to do 31 times 2.31, which we'll do over here on our calculator. Beep, 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 beep. And we should get 71.61. So that is the new parameter for the month of March. So now we're going to do the new variable, I guess we could call this M, is a distribution of Poisson with the parameter of 71.61. And again, we're looking for at least 81, so that's 81 or more. Okay, think of if I've got $10, if I got at least $10 in my pocket, then I have maybe 10, but I could have possibly more. So we need at least 81. So we're looking for the probability that M is greater than or equal to 81. And so we should be able to go straight into our calculator. Again, we're going to do a Poisson CDF. I'm going to type that in. And then we will put in our parameter, which is 71.61. And then again, we want 81 or larger. So we'll type in from 81, comma, up to whatever number you want, 10,000. Again, you could do the opposite and subtract it from 1, and that would work as well. All right, and we push enter, and we should get our answer, which is 0.147. So pretty small probability that you're going to have more than 81 cancellations in a month. Though we say that's small, but still that would be maybe twice, two months a year that you would get that. All right. Okay, on to letter C. C says find in 2 different ways the probability that there are no cancellations in a working week of 5 days. Okay, so now I need a new distribution. I'm going to call this distribution F because it's 5 days. That'll be a Poisson. and I need to take my 1 day, which is 2.31, and multiply it by the 5 days, and so I will get 11.55. Okay, now it does want us to do this in two ways. So this is the first way, is we can get the Poisson for a week, right? Once we have that, then we should be able to go ahead and put it into our calculator. Remember, finding no cancellations in the working week. So we're going to go Poisson. This time we want PDF because we only want a single value of no cancellations. So I go Poisson PDF, and then in order to get that, we'll go ahead and put in our parameter, which is 11.55, and then we will put comma and 0 because that's the only thing we want, 0, and we'll push enter, and we get 0. How many zeros is that? That's a lot of zeros. 1, 2, 3, 4, 5 zeros, and then 964. So my calculator right now is showing 0.00001, right? Which is not what I got here. The reason is because my calculator right now is in 5 decimals. If you ever get 4 numbers and then only 1 number at the end, chances are your calculator is not giving you all of the digits. It might be set to only give you 5 or 6 digits or something. So what we're going to do is we're going to go into doc here, and we're going to try to change the settings, document settings here. So settings, document settings, and see right now it says display digits float 6. That's why it's only giving me the first 6 digits. So I'm going to go down here, and I'm going to choose float 9. And so now if I do that same thing again, then it'll give me the answer that I got before. Okay, as an answer. Now it does say 2 different ways. Okay, well, what's another way that I can get 0? This is interesting because this is kind of a proof that what we're doing, I just kind of told you that, when we went to a month, we could take the expected value and just multiply it by the number of days, right? 31 days. We did something similar on the last question as well. But this is going to kind of solidify that understanding or that belief that this actually works. I mean, it should, because it's an expected value. An expected value for a day, if you have the same expected value over 2 days, then your total expected value for the 2 days is the sum of those two. I mean, that just makes sense. But this will kind of show us that that actually works. So what we're going to do is we're going to use the original one, which is that the C is a Poisson of 2.31. And we're going to find out the probability of getting 0 cancellations in 1 day, right? So again, we're going to do a Poisson PDF. And when we do this Poisson PDF, we'll go ahead and, again, we'll put in the 2.31. And then we will, then we will put in the 0, saying that we want 0 cancellations that week. Once we've done that, we push enter, and that answer we're going to take to the power of 5, because the probability of it happening 1 day, and then the next day, and then the next day, remember, we're assuming, according to Poisson, we're assuming that each event is not affected by the other events. Therefore, they are independent of each other. And so we can take each day. We want the first day to be 0, and the second day to be 0, and the third day, and the fourth day, and the fifth day. And when we do that with independent events, then we should just be able to multiply those together. And when we multiply those together, we get, lo and behold, the same thing that we had before. Awesome, huh? So obviously it's working. At least it gave us the same number both times. All right, let's go on to letter D. So letter D says, in a working week of 5 days, find the probability that there will be 4 or more cancellations on exactly 3 of these days. Now, this can be a little bit tricky, okay? I don't know if you caught it, but D is not a Poisson distribution. This is not a Poisson distribution. We may need a Poisson distribution in it, but what it's asking for is find the probability that there will be 4 or more cancellations on exactly 3 of these days. So it's saying, day 1, are there 4 or more cancellations? Yes or no? Day 2, are there 4 or more cancellations? Yes or no? Day 3, are there 4 or more cancellations? Yes or no? Can you hear what that's sounding like? It's a binomial distribution, isn't it? Okay, now we do need the Poisson distribution first because it does want us to find the probability of having 4 or more cancellations on one day. Okay, that's actually what we did in the first step, right, up here, the 0.203. So that's actually what we're going to use down here. But this, the week of 5 days, I'm going to call it, I guess I already used an F, so we'll just call this D for days. Okay, this distribution is not Poisson, it's a binomial distribution, right? It's a binomial distribution for which we have 5 trials, 5 different days, and on each of those days, there is a 0.203 probability of having 4 or more cancellations on that day. So it is a binomial distribution. Now, what we want is we want the binomial CDF, right? Or, sorry, we don't want CDF. We want exactly 3 of those days. So we're going to do a binom PDF, which we're going to put into our calculator. And we're going to give it the n, and we're going to give it the probability, and then we're going to tell it to do exactly 3 days, and we're going to get the probability there. And the probability there will be 0.0531, as you can see that we just got. All right, so there you go. That's question number 2. Hopefully that's helpful. This binomial, this last question, the D, is a very tricky question because, like I told you before, they're not going to say, use a binomial distribution. The binomial you have to be so comfortable with that you recognize it when it comes up. And honestly, if you have a Poisson or even a normal distribution question, which is what we're doing next, you should keep your eyes open for one of those middle or later pieces of the question to actually be a binomial distribution, not Poisson or whatever we started with. All right, so there you go. That's the end of this video, and I got one more for you.